So once you know how to graph, what we like to do is we like to interpret graphs, meaning figure out what's going on in the relationship when we see the graph of it. And there are two types of graphs, and interpretation of them is slightly different because the purpose is different. So there are graphs of data, which we call scatter plots. And those are literally just a plotting of independent versus dependent variables. And over here, we have graphs of equations, where I give you an equation and you graph it. The primary difference is that when you graph data from an experiment, you're trying to figure out if there's actually a relationship between the two variables you're studying. When I give you an equation, I literally give you the relationship between x and y, and I just want to see what it looks like. So we're going to start off by talking about data. We don't spend a lot of time on data, graphing data. That's what you do in your science class. We'll look at it more when we can get some real-world examples, mainly in the exponential growth unit and decay unit. That's when we're going to start making some scatter plots, or make more than we do at the beginning of the year. So the first thing is a scatter plot has an x-axis and a y-axis. And on the x-axis, we plot our independent variable. And on the y-axis, we plot our dependent variable. And when we have a scatter plot, or when we're doing an experiment, one of three things can pretty much happen with our data. So our data points can follow a trend upwards, like so. They can follow a trend downwards, like so. Or they can just be totally crazy and random. Okay? So if you do an experiment and your data trends upward, we say that there is a positive correlation between the independent and dependent variables. And what that means is that as your independent variable increases in value, the dependent variable increases with it. So as x gets bigger, y gets bigger. And that gives you a positive correlation. And so that means that this one that has a downward trend, if your variables have a downward trend, we say that your variables have a negative correlation. So that means as the x values increase, the y values decrease. So that's a negative correlation. Now if you graph your data from an experiment and you get some random mess like this, that means you didn't find much in your experiment, because there is no correlation when it's all random and there's no trend. That means there's no relationship between the dependent and independent variables. It's like saying that whether or not you wore jeans to class is going to tell you what kind of grade you're going to make in the class. Has no bearing whatsoever. So those variables aren't related to each other. And when you graph them, there'd be absolutely no correlation. All right? So now equations are different, as I said, because here you're trying to figure out what the relationship is. Here I give you the relationship. So for example, if I give you y equals x squared, I am telling you the relationship between the x and the y. I'm telling you that every single y value is generated by taking the x value and squaring it. And so if I graph this, I'm going to get a graph called a parabola. Y equals x squared is called a quadratic relationship, and their graphs are parabolas. And I'm going to try my best to sketch a parabola. And they're supposed to be U-shaped and symmetrical. Mine is not so much, but it's just a sketch, so it's okay. And I can learn a lot about the relationship y equals x squared from its graph. I know that there are repeated y values. I know that it's all non-negative, that up here everything is positive. There's nothing that goes on down there. And I can tell a lot about what is happening with the variables. It's getting kind of steeper and steeper and steeper as I move away from the y-axis. So when I interpret a graph like this, I just don't want to say it goes up and then it comes back, or it goes down and then comes back up. Right? That's an elementary school answer. Like, I wanted you to tell me specifically what's going on. Going down and then coming back up is not acceptable. I want to know how things are going down. Are they going down at a steady rate? Is the rate increasing? Is it decreasing? Is the steepness changing? Is it increasing or decreasing? And if you think about every single graph you're going to get in mathematics, they can pretty much be broken down into one of 7 shapes. And there are 3 line segment shapes and 4 curves that you can break anything pretty much down to. So let's look at the line segment shapes first. So if I give you pieces of graphs, you can tell me what's happening in that piece. So I can give you a piece that looks like this, a horizontal line piece. I can give you a piece that looks like this. It's an increasing line piece. I can give you a piece that looks like that. It's a decreasing line piece. and you can tell me exactly what's happening with the dependent variable, or let's actually say the y value. Okay, so what's happening to the y value here? Well, the y value is staying the same. It's constant. Right, and what's happening to the y value here? Well, it's increasing. And this is always as x is getting bigger. This is increasing. And what's happening to the y value here? Well, it's decreasing. So I can say more, too. I can actually tell you how things are increasing or decreasing. And we call that looking at the rate of change, which I'm going to abbreviate ROC. So rate of change. And that's how something is changing. Is it speeding up? Is it staying the same? Or is it changing by the same amount each time? Now in this case, my rate of change is literally 0, because is my y value changing? No. As my x value goes along, my y value stays exactly the same. So there is absolutely no change here. But if I look at this, and I say, well, how is my y value changing here? Well, it's going up by a certain amount and then over. And then up by the exact same amount and then over by the same amount. So it's changing at a constant rate. So it's like going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, over and over and over again. So we say its rate of change is constant, and that's what actually makes it a line. And so if I look over at this rate of change, it's the same thing. It's like going down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. It's always changing by the exact same amount, so this rate of change is also constant. And that's pretty much all that can happen with lines. So if I give you, for example, the graph of y equals the absolute value of x. So if you were to graph the y equals the absolute value of x, it's going to look like this. So if I were to describe this graph, I say, well, at first it's decreasing at a constant rate of change, and then at the origin it changes and it becomes increasing at a constant rate of change. So I can be more specific than it goes down and then it comes back up, right? Okay, so those are the straight line segments. Now there are 4 curves that we can look at, or 4 types of curves we can look at. There's the curve that looks like that. There's the curve that looks like that. Those are the 2 increasing curves. And then I can have a curve that looks like that, or I can have a curve that looks like that. These are the 2 decreasing curves. So when I describe these by their y values first, I can say this one has an increasing y value, as does this one. These both have increasing y values. Because as the x value increases, what happens to the y value? It gets higher and higher and higher and higher. And so then, of course, these guys over here have decreasing y values. Because as the x value increases, the y values get smaller and smaller and smaller and smaller. Now what's interesting with the curves is the rate of change, okay? Because they're not constant, they don't stay the same. That's actually how you make it curvy. And the best way to think of this is knowing that steepness means faster change. So if I look at this little point here, and I'm going to keep this 3.5-inch mark on my ruler, and I'm going to trace along the curve, and I'm going to see what happens to the steepness of my ruler. At first, it's not steep at all, meaning there's very slow change. But as I follow the curve, what happens? Well, my line gets steeper and steeper and steeper and steeper. So what happens is my rate of change is increasing. So as I start off here, I'm not going really fast and changing in the y, but as I move up and up and up and up, I'm moving further and further away. So it's like I move up 1 and then over 1, but then I move up 2 and then over 1. Then I move up 3 and then over 1. Then up 4, then over 1. So my rate of change with this shape is increasing. Now if I look at this graph here and I do the same thing, I'm going to have one point in my ruler follow the shape of the curve. It starts off super steep, but then as I follow along the curve, what happens to the steepness? The steepness becomes less and less and less and less and less. So what's happening to my rate of change is that it's decreasing here. So it's like I went up 4, then over 1, then up 3, and then over 1, and then up 2, and then over 1, and then up 1 and over 1, and then like up a half and over 1. So it's like I'm slowing down. And if I look at this one, I start off super steep. I mean, I'm starting off really, really fast, but then as I move along the curve, what happens to my line? It gets less and less steep. So what's happening to my rate of change here? My rate of change here is decreasing. So it's like I'm slowing down. Like I hit traffic. So at first, like I live really far away from school and I'm driving and I can go really, really fast, but then I hit I-35 and I have to slow down. So my rate of change is decreasing. And then here, my rate of change is increasing because that's the only one left. Because if I look at its steepness, it starts off really, really not so steep. But then as I continue along the curve, what happens to the steepness? The steepness increases, so I get faster and faster and faster. So it's like in the morning, I'm kind of slow, and I'm getting out of bed and walking around the house really slow, but then, I'm like, oh no, I'm gonna be late. So I start speeding up as, gets closer and closer for me to get to work. So that's how I can interpret a graph. So if I go back and I look at my parabola, I can say that, oh, my y values are decreasing, right? And the rate of change, they are slowing down. So it's decreasing at a fast rate first, but then it slows down and hits this point. And then all of a sudden at 0, 0, my y values begin to increase. And at first the change is really slow, but my rate of change is increasing and it gets faster and faster and faster. So I don't have to just say it goes down and then back up. I can say how it goes down and then how it comes back up. And that's how we're going to interpret graphs for equations.